Our next speaker is from the ECE department. Her name is Dr. Sanaa Sharafeddine, and she's going to keep us in the air, but a little bit differently this time. So her title of her talk is Networks in the Air, Twins on the Cloud. Let's see what that's about. Sounds interesting. So please welcome Sanaa Sharafeddine.
Okay, well, networks are not only in the air, but networks are underwater. Can I have the clicker? Lebanon is connected to the rest of the world through Cyprus and Egypt. And this is through fiber technologies. Network exists on the surface of the earth. Using Wi-Fi or cellular technologies, networks also exist in space through satellites. And all of these different kinds of networks, they can join now a unified platform, where all kinds of communication can take place. And these communications can take place anywhere, anytime, and from any device. And actually from anything, living or non-living thing. And it's now the era of the Internet of Everything. So everything can literally be connected to the Internet, and not only to deliver audio and visual, but also to deliver smell, taste, and touch. We've been witnessing a huge surge or a continuous surge of mobile subscriptions over the years. So here we can see the number of mobile subscriptions in billions over time for the different generations of cellular technologies like 2G, 3G, 4G, and this orange one is 5G. 5G has been revolutionary in the types of applications that are being evolved, and they will continue to evolve until like 6G, which is the future wireless networks, which is expected to appear by 2029. So 5G actually, it has enhanced the network capabilities on 3 fronts by increasing the speed rate at which networks can communicate, by allowing a huge number of IoT devices and sensors to communicate with each other in a small geographical area to allow massive communication. And also it introduced what's called as ultra-reliable low-latency communication. And with this, I mean I need to deliver amount of data with extremely low delay and extremely high reliability. And this kind of communication, which is URLLC communication, it allows a new set of applications, like mission-critical applications, such as remote surgeries, for example. So you can have a physician operating on a patient on the other end of the world. So certainly we would need every command which is sent by the surgeon to be sent right away to the patient and with extremely high reliability. So these capabilities, actually, they have unfolded a new set of applications like autonomous driving, but we're still not there. It has also started holographic teleportation, but yet we're still not there. So that means the future wireless technology, which is 6G, is expected to push beyond the technical boundaries of 5G, and in order to fulfill their full potential. And this is by having the bit rates to be extremely increased, by having massive communication to be even extreme, by having a huge number of IoT devices communicating with each other, and also hyper-reliable low-latency communication in order to enable even open-heart surgeries to be performed online. So in addition to these different dimensions of capabilities that is supported or that's expected to be expanded by 6G, 6G is also exploring a new set of capabilities or new dimensions of capabilities by integrating more AI, more intelligence into the network, and by also providing ubiquitous and seamless connectivity regardless of the location. There's another dimension, which is the integrated sensing and communication. And with sensing in here, I mean it's radar-like functions. So I need radar-like functionality to cooperate with communication in a seamless manner. So such kind of capability will allow autonomous driving to take place, because regardless of the vehicle that you are using and regardless of the number of sensors this vehicle will be equipped with, this vehicle won't be able to see across the corner. So you would need this radar functionality, which will be mounted on the top of the communication base station in order to scan the area and communicate this information right away to the vehicle so that they know their surroundings. Integrated sensing and communication is also needed in order to bring the digital world as close as possible to the physical world. And as Bilal just mentioned, we do have these digital twins. So what we need to have is that every physical system that we have will be having a replica, a digital copy in the network. And with integration, we can start with the lowest degrees of integration, where simply this radar can be mounted on the same tower of the communication base station, all the way to a full integration where we'll be using the same hardware and also the same signals. And these signals will be using to deliver information as well as sensing or detection of targets and tracking these targets. In this work in here, what we have explored, we explored the full integration of sensing and communication, where we have this base station delivering content to a number of users, while at the same time using the same signal, we need to detect the existence of a target, which is also a drone in that case. So these users, in order to help with the sensing capability and improve the echo signal that will be received in here, and what they will do is that they will relay the signal which is sent by the transmitting base station to the target in order to improve the power at which this echo signal will be received. In order to solve this problem, we have used traditional optimization techniques in order to improve or to solve our problem. And then we tried to test the performance that we would get. And the performances and the simulations that we were able to perform were only limited to small-scale networks. So we're not able to scale to larger networks and to test the solution on more complex networks. The thing is that if we need to use traditionally engineered networks, the performance will hit a plateau and we won't be able to increase further. So certainly we would need to have more intelligence integrated within my network. Plus, in order to get even more performances, we would need to have an AI native network. And with this, I mean we need intelligence to be on the user devices, intelligence to be in the network core, in all the equipments, as well intelligence in the environment. So we also need the environment to be smart, to guide the signals where to travel and reach the destined target. So it's indeed AI has been driving mobile networks advancement, but when you come to think about it, also mobile networks are driving significantly AI advancement. So all of these AI models, generative AI that we are heavily using, they do really rely on data collection. And all of this data collection is done through these mobile networks that are always collecting data and transferring this data to these AI models. So this is in one way. Another way that mobile networks are also improving with AI advancement is that mobile networks are providing access to users at all times to these complex models. And it's expected that the mobile traffic, which is generated by generative AI, to increase over the next 10 years. And this mobile traffic can also be used to build these digital twins where we'll have complex learning algorithms to optimize the system and provide better decision making. So for example, here, if I need to build a digital twin for this smart city, we would need to have a huge number of sensors distributed, taking all kinds of information and delivering this data to the digital twin, which resides on the cloud, that the data will be processed. As I said, we'll have more learning and more optimization that is being done in order to optimize the performance of the smart city and increase its efficiency. And this is what actually we attempt to do in this work. So here we wanted to build a high fidelity digital twin and for industrial facility. And with high fidelity, I mean I need to build a digital twin which is an exact replica of the physical system. That is, it has to be as accurate as possible to the physical system and as synchronized as possible with the physical system. So the status that will be reflected by the digital twin should reflect the current status of the physical system that we have at hand. So here is my digital twin, which resides on the base station. In order to build that digital twin, we will be having lots of sensors and IoT devices to collect information, to continuously read measurements from the different industrial equipment. And all of this data needs to be transferred to the digital twin for processing but maybe because these devices, they have low transmit power, they won't be able to transmit right away to the base station. Also, depending on their location, they might not have a good connectivity with the base station. So what we did is that we leveraged a drone in order to collect all of this data, process this data, and only send the meaningful information to the base station in order to update the status of the digital twin. So digital twins are not only restricted to industrial facilities, to physical systems, we can also have digital twins for the human body and even for the organs. So to do so, certainly lots of different kinds of sensors should be involved, such as like chemical, electrical, mechanical sensors to collect all sorts of data. And this data then will be used in order to predict, for example, if a certain disease might happen to that person or a medical condition. And more so, we can also use the digital twin in order to test the reaction or the behavior of this digital twin of the body after administering a certain drug or a medicine or even a procedure. And based on the analysis, the doctor would decide whether to give that drug to the patient or not. Also, digital twins, they may be used in order to identify the root causes for a specific medical condition. So after all of these advancements about digital twins and holograms, let's move fast forward to IDS 2040. So despite all of these technological advancements, I hope by then we will not be sending our holograms to participate in the conference. Thank you.
Thank you so much, Sanaa. We'll open the floor up for questions again, please.
I'm super concerned about the whole digital twin things, because I find that this is a tremendous tool of surveillance and control over people. Is this something that you consider when you plan and design things like that?
Actually, certainly it's a major concern, and I think privacy stays to be a major concern, but sometimes you feel it's uncontrollable. So there's a lot of data which is being collected from you at all times, and AI, generative AI that we've been using has reached already like a static performance. To be able to advance, they need even more data to be collected from us. And I think sometimes we do provide this data because the way we deal with generative AI, we need really a personalized assistant. So as if I need this generative AI to be like my digital twin and like to reflect the best version of me while preserving my identity, my voice, and my process of thinking.
I want to dig further. I'm sorry, Jason, because we're still in a war where people have been targeted, surgically, but through means that we do not understand. And you know what I'm referring to. Isn't this going to even add further to the ability of having a surgical removal of undesirable
It's true,
people?
yes. So, and I think it's unavoidable somehow.
Really?
So there's a lot of work with Professor Isa and the rest to try to preserve privacy.
It's from a purely humanist
It's always
position.
the case, like technology advances, and then you have to run after it and try to secure and protect.
Okay.
Yeah.
I'm curious, who's sitting next to Professor Shahade?
That's Brahim. Yeah, so this is the photo that I saw on,
That's it?